All right, welcome. This is a video on significant figures, and I'm just going to kick it right off. So significant figures are important because of this word, precision. And so precision is talking about the exactness of a measurement. And so when we're measuring something, whatever tool we're using to measure it has a certain amount of precision, meaning it's going to round at some point. So I picked a really basic number here, the number 100. The precision here is very low. Our exactness isn't with this number because we only have one significant digit. I'm going to get to what that means in a little bit. But if you think about the number 100, how could we round to get that number? Well, if I had the number 50, that number would round up to the number 100. Also, on the other end, if I had the number 149, that number would round down to the number 100. And so that 100, if I was writing this on a test or something, is representing a range of numbers anywhere from number 50 all the way up through 149. So we're covering a wide range there, which is why we say it is not precise. We can make this number more precise by putting a decimal place on the end. If we make it 100 with a decimal place, now in order to round and we're sure that that 0 is actually a 0, my range is going to be much tighter. The numbers that would round to 100 with the decimal would be 99.5, right? That 5 would tell me to round up, and then we get to our 100, all the way through 100.49. And so my range of digits that would round to 100 with the decimal place is much smaller, and that's significant figures. So there's a couple of rules. First rule is very simple. Anything that's not a 0, 4, a 5, a 1, those are all significant digits. And so this would have 3 sig figs in it. I'll let you solve number 2 on your own. The second rule is called the sandwich rule. At least that's what I call it. And the sandwich rule says that if you have a 0 between non-zeros, that 0 is also significant. So the 5 is a significant digit because it isn't a 0. Same is the case for that 5. This one, because it's sandwiched, that 0 would also become significant. And so we have 3 significant digits here as well. This number over here, all of these zeros are significant because we've got a non-zero on either end. And so that's the sandwich rule. Again, feel free to make up a couple numbers on your own and see if you can determine how many sig digits there are. Number 3 is talking about trailing zeros, and a trailing zero is any 0 after the non-zero. So we've got a 1 and we've got a 1 as our non-zeros. Those are guaranteed significant. Any trailing 0 is insignificant unless you have a decimal place. So we have a decimal place in this number. We're going to kind of treat that like a significant digit. It's not going to count to our total, but it's going to sandwich these zeros in between. And so because of the decimal, 1, 2, 3 zeros are all significant digits. And so this becomes 4 sig figs. The number over here has no decimal, and so we only have 1 sig fig. And so while these look to be the exact same number, the precision, this is a very precise number over here, does not exist on this one. This is a very imprecise number, and that gets back to my first example. This number down here, another example I drew up for you, the 1 is definitely a significant figure because it's not a 0. We have a decimal place, and so significant, 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 significant. All of them become, because they're all to the right of that 1, and we have a decimal, they're all significant. So this would be a total of 6 sig figs in that number. Number 4, leading zeros. So these would be zeros that are falling before our non-zero. So for number 1, this is a very silly way to write a number, but believe me, it's probably been done before. 5 and 4 are not zeros, they're automatically significant. The zeros out front, they're to the left. According to rule 4, they do not count, and so this would just be the number 54 with 2 sig figs. If we put a decimal place there, this rule does not have an exception. So because they're still to the left of our 2 non-zeros, all of these zeros are also insignificant. So we have 2 digits. What about number 3? In number 3, I've got non-zero, non-zero, both significant. Check it out, we've got some zeros between them, so these are sandwich rule significant. These ones are to the left of my non-zero, in which case being the 5. They don't count as significant digits, so this one would have 4 sig figs in it. Number 4, 5, 4, always significant, not 0. This is a sandwich rule 0 here, so that one is also significant. We've got a decimal place in this number, so my zeros to the right of the 4 are also significant. Anything to the left of the 5 that is a 0 are insignificant. There's nothing out in front there that would make them good. So this is also 4 sig figs. So those are the rules to follow. This is kind of why we have those rules, is so we know for rounding in this problem or these types of problems. So multiplication, division, they follow the same rule. The number of sig figs in the problem will tell you how many you're allowed to have in your answer. In this case, it's the least number of significant digits. So in 5.5, both of these are non-zeros. I have 2 sig figs. In the number 10, there's no 0 there. So this is one significant digit. So my answer must have only one significant digit. So I'm going to have to round it. If I multiply these two in my calculator, it'll say I have 55 as the answer. This number is too precise based on the numbers we got, and so we must round this to one sig fig. The 5 in front for 50 is going to be that significant figure we're going to round to. The 5 following it in the ones place tells me to round it up, and so my answer here is actually going to be 60. All right, so don't trust your calculator on these. The calculator does not know significant figures, and so you actually have to round based on what the calculator gives you. For the next problem, we have a decimal place here, so all of my digits are significant. 1, 2, 3, 4, 5, 6 sig figs. My 13.5 has 3 sig figs. They're all non-zeros, and so my answer must have 3 sig figs in it. So we type this into the calculator. 1,000 divided by 13.5 gives me a number like this, 74.074 repeating. I'm only allowed to have 3 sig figs, so I'm going to keep the 7, I'm going to keep the 4. The 0 here after the decimal place is where I'm going to round to. It's followed by a 7, so I'm going to also round that one up. So this becomes 74.1 as my final answer. Adding and subtracting. This rule is a little different. We're not counting sig figs here. We're just counting digits after the decimal place. Those are the ones that we're paying attention to. So 6.5 has 1 digit after the decimal place. 12 has 0 digits after the decimal place. Doesn't even have a decimal. 9.04 has 3 digits after the decimal place. So my answer for this problem must have as many digits after the decimal as the least. So that would be 0 digits after the decimal. It doesn't matter how many digits I have before the decimal. So 6.5 plus 12 plus 9.004 gives me the answer of 27.504. I'm looking at this digit here because it's going to tell me how to round my 7. Remember, I'm not allowed to have any digits after the decimal, so this is going to be 28. The 5 will round me up to 28, and so that is the correct answer using significant figures. Same is true for subtraction. So I have 2 after the decimal, both 5s, and I've got 3 after the decimal. So my answer must have 2 digits after the decimal for this subtraction problem. So 15.55 minus 45.656 equals negative 30.106. Remember, I'm supposed to have 2 digits after the decimal, so I'm going to keep the 1. I want to look at the 0. The 0 is going to be rounded up because I've got a 6 after it, so this becomes negative 30.11 as my final answer, and we drop that last digit because we're not allowed to have it. So that's been a quick run through on significant figures. I hope the video is helpful. Feel free to watch and replay as much as you need to. I've tried to cover everything as quick as possible, so feel free to ask questions when you come back to class. Thanks for watching.